All right, folks, this is our second example. We are going to use this table to write a function, and we're going to follow these steps. Just like you did in the previous video, please write these 4 steps down in your notebook. First thing we're going to do is we're going to identify the... Oh, sorry, I grabbed the wrong one. This is regress. Here we go. Writing equations from a table. First thing we're going to do is determine the first difference. So when I give you a table and I ask you to write an equation, we're going to have the input, we're going to have the output. You're going to need to fill in the process portion, the middle column, in order to figure out what the equation is. The first difference is figuring out the difference between your input values to figure out the difference between your output values. We're going to go 1 minus negative 1. How do I go from negative 1 to 1? How do I go from negative 1 to 1? I add 2. That's a positive 2. How do I go from 1 to 2? I add 1. How do I go from 4 to negative 2? I subtract 6. How do I go from negative 2 to negative 5? I subtract 3. Now let's take a look. If we change in y over change in x, my rise, which is the y, over the run, which is the x, that's going to give me negative 6 over 2. And then this one I have negative 3 over 1. Well, take a look, folks. What's negative 6? How can I reduce this fraction down? I can divide by 2, so that's going to equal negative 3 over 1. Oh, take a look. These are the same. Therefore, this is in fact a line, and this is in fact my rate of change. So I've determined the first difference. I'm going to write the slope in the process column. The slope is the same thing as the rate of change. So right here, I'm going to write 3 over 1, negative 3 over 1. I'm going to write negative 3 over 1. I'm going to write negative 3 over 1. Now, step number 3 is to substitute the domain value into the process column. Domain values are right here, negative 1, 1, and 2. Negative 1, 1, and 2. What's negative 3 times negative 1? A negative times a negative is a positive. Therefore, this is going to be a positive 3. What's negative 3 times 1? Negative 3. And what is negative 3 times 2? Negative 6. Now, how do I get from 3, because I've done this part, I've done m times x, now we're trying to figure out b. What do I need to add right here? And this is step 4. Step 4 is determine your initial value. Your initial value is the same thing as your y-intercept on a graph. So to find our initial value, to find out what value we started with, if we have 3 and we need to get to 4, what do I need to do? I need to add 1. If I am at negative 3 and I need to get to negative 2, what do? That's negative 1. That's positive 1. I add 1. If I'm at negative 6, how do I get to negative 5? I add 1. So here we have our m, which is negative 3, our x, and our b is positive 1. So our equation is y equals negative 3x plus 1. So over here I've determined the rate of change, which is negative 3. I've determined the initial value, which is 1. Our equation is y equals negative 3x plus 1. What are the coordinates of the y-intercept? Y-intercept, this is our initial value. It's always going to be 0, 1. What are the coordinates of the x-intercept? Well, ladies and gentlemen, you might have to graph. And is this a continuous, is this a function? You should graph it. Is this function continuous or discrete? If I'm dealing with length, is length continuous or discrete? Is it something that cannot be broken down? Is it something that I count, or is it something that I measure? Length is something that I measure, and therefore it is continuous because I measure it. Now the domain and range, you might want to graph this on your calculator. You want to think through what we've got here. Since it's continuous, what notation are we going to be using for the input and outputs? What is the input value when the output is 1? Well, if my output is 1, what is my input value going to be? You might, since we have an equation, you should be able to solve for the answer. If my output, what is my output value when my input is 3? Sorry, my calculator's doing crazy. My phone is doing crazy things right now. Sorry, that got out of focus. If the input is negative 3, if this is my x value, can we substitute that into the equation to figure out the output? I think we can. And then how does this function compare to the parent function? Well, let's take a look. We know that the parent function is y equals x, and we know that this one is y equals negative 3x plus 1. Well, here we know that y-intercept is 0. We know that this moves up 1 unit. Now, if you were to graph this, is that negative 3, is that going to be steeper? Is it going to be steeper or less steep? Is it going to be closer to the x-axis or is it going to be closer to the y-axis? I think this one's going to be more steep. It's going to be closer to the y-axis. You can graph this on the calculator. I'll show you how to do that if you don't know how in class. So this is going to be steeper than the parent function. Ladies and gentlemen, you're going to have 4 problems like this, and that's it. That's all. That's exactly how to work the problem.